I have a lot of questions about open source, Brad.
Yeah, well, I've got some answers.
What is open source?
Well, Webster's Dictionary defines open source.
No.
Yeah, we got a lot of requests after the last couple weeks to sort of work backwards a little bit and let's say start from first principles regarding open source and kind of introduce basic concepts, define basic terms, just sort of do a basic explainer for people who are FOSS curious, let's say, but don't have a lot of in-depth knowledge. So that's what we're here to do.
A jumping off place, if you will. So yeah, we're going to get into some, like everything from like how licenses work and why licenses are important and why they're kind of a little bit of legal magic. And then we're going to get all the way down into like how you distribute code to people, how you download apps, how you get them on different platforms, and probably even talk a little bit about what platforms are, I guess.
Yeah, I mean, I feel like people who are not developers probably are running into more and more of these terms, through osmosis, or just kind of bumping up against things like repo and fork and Git versus GitHub and just version control. Yes?
My dad asked me the other day if it was safe to download stuff from GitHub.
Your dad should listen to this podcast.
I think he does.
Oh boy, that's too much pressure. Okay, we should get this thing started, but yeah, we're kind of keeping with our theme here of sort of working backwards into more and more basic introductory episodes here in reverse order. So I look forward to the next episode that we do, in which I will have invented the Linux kernel from scratch.
Welcome to the FOSS Pod. I'm Will.
I'm Brad.
Hey, Brad, how you doing?
I'm doing well. How are you? I've got this mobile recording set up. I'm on a laptop and got a microphone stand sitting in front of me. I'm in a different house, but same podcast.
Do you find when you podcast in a different venue that it changes the way you think about podcasting?
Well, it definitely changes the acoustics.
That's true, a little bit,
I'm in a large basement right now. There's a very old refrigerator next to me that keeps kicking on, and I don't know if that compressor is going to come through or not, but let's find out.
I mean, look, sometimes you podcast where you got a podcast, right?
Nothing stops podcasting.
No, well, hold on. Let's not get crazy. I got to record once in like a real actual professional studio, like with a glass wall and a producer and all that behind me on the other side. It was amazing. It's a lot of pressure, though.
Living high on the hog, we would say around here.
Yeah, my name's not cool enough to work in NPR studios on the reg, though.
But you just need to come up with your podonym.
I mean, it's Will Smith, man.
Okay, fine. Let's move on.
As always, this week's episode of the FOSS Pod is brought to you by Google Open Source. They bring all the value of open source to Google and all the resources of Google to open source. Right now, they have a live event happening at the end of this month about removing Docker shim. It's going to be very exciting, trust me. You can find the link in the show notes if you are interested in that sort of thing. It's about the deprecation of old technology from Kubernetes. I don't know. I know what some of those words mean, but not in this context. But you can find out more at the link in the show notes or at opensource.google.
Out with the old runtimes, in with the new. That's what I always say.
Deprecate everything. That's what I say. As we hinted in the cold open, this is the intro. This is a primer. If you have been listening to what we've been talking about, you've not understood what a repo is. You don't understand why licenses matter. You don't understand what a maintainer, why it was cool that we got to talk to Jim because he's the maintainer for OBS on the first episode. We're going to explain all of that stuff today and hopefully give you a good first place to go to understand what's what in the world of open source, because there's a lot of lingo.
There's a lot of lingo, a lot of jargon, and yeah, I think we're hoping to lay some groundwork here for people who are just kind of starting to dabble in this world, for us to do kind of more in-depth episodes later on different projects and talking to other, maintainers and open source developers, kind of give everybody a basic working knowledge of all this stuff so we can move forward.
And if you already know all this stuff, then not next week's, but the next episode is going to be something that you're going to be excited about, because we're back into talking to maintainers and stuff like that is the plan for
yes.
episode 5.
Got some developers of some notable projects that we will be looking to talk to.
We have really cool people coming.
Yeah.
It's very exciting.
I'm excited. The nerdier the project, the more excited I get, it turns out.
But we should get into this now. We should get going, because there's a lot of ground to cover here.
There is. I'll just say, as a listener of the Tech Pod told me once, the people who already know all this stuff can just sit there and nod sagely at how absolutely correct we are about all of this.
And if you want to scream at the radio, the email address is fosspod@content.town.
Yeah.
Okay, so let's start at the beginning. Source code. This is the fundamental thing. This is where we start. It's the thing that makes software into programs.
Source code is literally the code that programmers type into a computer that becomes software. I mean, it's the human-readable programming language that software is written in, by and large. That's the kind of generic definition.
And there's a couple of different ways that you can do this. It can be as simple as a script that you run on the computer that's just the programmer telling the computer, do these things in this order, all the way up to a language that generates windows and stuff like that on your screen. There's a lot of complexity, it seems like, but it also can be very simple.
Mm-hmm.
Like you can write a script that says, hey, every time a file lands in this folder, copy it to this other folder. And that's the entirety of what it does. That's code. That's source code.
Right. And that's something you just feed right into whatever scripting framework. You don't have to compile it into software. It's probably just a single text file that is 5 lines long, 10 lines, 20, 100, but like a short thing. But modern software is massive and sprawling and has a ton of people contributing to it and exists in numerous files and can be thousands and thousands of lines. And that's where most of the concepts we're going to get into in this episode come in. To manage things that are that complex, you need a lot of tools and a pretty robust framework. So
okay, so the next thing is open source versus closed source. This is a conversation that started at the dawn of computing, really, because in the beginning, everything was open. Like people just wrote code and shared it because I don't know why. It's just it didn't occur to anyone, I think, for a while that this was a proprietary advantage and that they should not share their work with everybody else.
You go back in time and read about the origins of computing and you realize how much it was run by just huge nerds who were very excited about the work they were doing and just wanted everybody to take part. You know, it's like this kind of digital commune. It was before large corporations came along and realized there was a lot of money to be made.
Are you suggesting that a rising tide lifts all boats, Brad?
Maybe. Let's explore that idea as we move forward.
So the thing that happened in the 80s, I guess 80s when the GNU Foundation started.
Yeah. The GNU movement was kind of the thing that spawned out of Unix and BSD, which we've talked about before, and kind of wanted software to continue to be open and freely usable by everyone at the same time that like the IBMs and Microsofts were also writing a lot of closed source software.
And protecting shareholder value, right?
Yes. So closed source, as the name implies, it's proprietary. It is not for free use by anyone. The code generally, there may be some minor exceptions, but generally the code is not open. Like it's not viewable by people.
Yeah. So if for example, if your copy of Windows has a problem, the only way you can get a fix for it is to hope that Microsoft comes in and fixes. Somebody at Microsoft opens up the source code, fixes the bug, recompiles it, and posts it in an update that your copy of Windows will download. As opposed to something like Linux or BSD, where the source code is available, you can just go to the repo for the OS, grab the code that has the bug, write your fix, send it back up to them, and they can choose to integrate it or not. Or you can just integrate it yourself if you so desire.
I started to say, what's a repo, Will? But that's
we'll get there.
We'll get there.
So the secret of open source is the license. And this is a thing that I didn't really appreciate until fairly recently. Licensing is important because of copyright. And I think a lot of people don't realize that copyright happens automatically by default, whether you do anything or not.
So that was a thing in the course of us planning this episode that I had no idea about. I thought that to copyright your work, you had to actively go through some kind of legal process to instate that. But apparently that's not the case. Can you help demystify that?
Yeah, so you know when you opened up a paint window and made a lollipop tree and then saved it and put this is an arrow that says that's copyrighted. Nobody else can use that by default. Yeah.
Should I put that on the modern art circuit and see what I can get?
I mean, look, you probably make 10,000 variations of it, make an NFT, make like $15, $20 if you're lucky. It's only going to cost a rainforest. Anyway, we don't need to get into that. That's a hot topic for some other future time, maybe, or not. But the default nature, the by default, and this is as opposed to, say, something like patenting or trademarking. Trademarking and patenting both require effort on the part of the person who creates it.
Okay.
So in order for you to get a patent, which is saying, hey, I have the idea, like I'm the first person who came up with this idea of this particular way of doing this thing, you have to hire a patent lawyer and you have to search for other similar things that may or may not apply. And then you fill out an application and then you get a patent if everything goes well, and it costs tens of thousands of dollars. Copyright doesn't work like that.
Patent process can be like months to years, right?
It takes a long time. Yeah.
Yeah. Okay.
And there's also different kinds of patents. Like that's a whole other topic for another day, probably, or maybe not actually. The point is, patents are less important to this process than copyright. The point of a software license in the open source sense is that it basically says, hey, I'm the owner of this work, and I'm giving other people permission to use this work if they follow these particular requirements. And those requirements can vary pretty dramatically based on the licensing structure that you choose, or whether you choose to go with something like a no license, which is another kind of way to handle licensing. So the neat thing about open source licenses is if you and I were working on a project together and we didn't have a license, in a kind of legal copyright sense, we wouldn't have the ability to work on each other's code because you own your code and you have exclusive license, you have exclusive use of it in perpetuity, and I own my code, and there's no agreement in place for you to work on my code and me to work on your code.
Right.
And that's what the open source licenses do. I mean, That's what, like, if you work in a company, that's covered by your employment contract, which says, okay, everything that Brad does while he's employed at this company is owned by company XYZ. And for example, our employment agreements for the podcast company say that the work that we do on these podcasts, which is copyrighted by default, is owned by the company and not by you or me individually. So,
and it should be obvious why that's an issue for software projects where there are a bunch of different source files, but also like different contributors will be working on the same source files. The fact that individual lines of code within a file could be copyrighted by one individual or another, it makes it pretty clear why you need a comprehensive license that defines what other people can do with a project.
It's impossible. It defines what you can do with it, and it defines what other people can do with your work, which are the two kind of important things. And there's different kinds of licenses. There's a ton of different kinds of licenses. You can do public domain dedications even. So you can say, hey, I don't want to own this code anymore. I don't want to have any liability for this code, which is another thing that licenses can assign. You know, most open source licenses say, hey, you can use this code for whatever you want. It's as is.
It's funny if you work with a lot of open source projects and you kind of glance at the headers where the licensing often lives, the one thing that will always be in all caps is like the software contains no warranty whatsoever. No warranty is implied, no liability. Like they're very upfront that, hey, what happens once you use this is your business and not ours.
Well, and the neat thing is over the last 30 years, 40 years, this stuff has been tried in court. We've had clarifications on a lot of the components of this. So we know it is legally tested and tried for the most part now, which was not the case when, you know, in the early days of Linux and stuff like that in the 90s when we were still kind of finding our way through this.
Should we talk about permissive versus non-permissive? I feel like that's probably the biggest dividing line in licenses.
Yeah, that's the big place so basically permissive licenses like the MIT license or certain versions of the BSD license, which are the common ones. I think Apache is another fairly permissive license. Basically, they say, hey, here's the code. You don't get a warranty. You can do whatever you want with it, but we're not going to support you or do anything to like keep it going. And that's kind of it. Like you can use it for commercial software. You can use it for open or closed source software. And there's no requirement for you to continue share liking the code that you write and contribute to this. You don't have to push anything back into the main repos. You can just take it and copy it and make it your own and then do whatever you want with it.
That's the key to me here is that the more permissive licenses allow you to take open free code, integrate it into something that you are going to sell and not publish the changes you've made to that code publicly for more people to use.
Yeah, I think that's fair.
Right, which is why a lot of open source software that is licensed permissively shows up in video game consoles and other operating systems and things that are run by corporations that don't want to make clear exactly what's happening under the hood of their devices versus a non-permissive license like the GPL requires you, if you use any GPL product or software as the basis for your project, you have to then make available any work you did with that GPL code as the basis. Does that make sense?
Yeah, and that is the big difference. Like the share alike clause is a big part of the non-permissive licenses. The other thing is some of the non-permissive licenses have clauses that are different levels of viral. So, for example, if you connect to GPL, I think v3 software using an API, theoretically any of the software that talks to that software should also be open source and shared, which is really clever if you want to make everything open source, but also means that in practicality, literally no one who's making any kind of commercial software is going to use your license for their code. There's a bunch of spinoffs of this stuff. We'll talk about some of them toward the end of the episode, but like Creative Commons is a good example. Creative Commons is for all the stuff that isn't code, but that you want to give these same kind of share alike and attribution, things like that. So for example, MIT, I think you have to, the difference between like MIT and BSD and some of the other more permissive licenses is some of them require you to disclose that you're using that code from that project, but they may not require that you share the source code for that project. Right. There's actually a site called choosealicense.com.
Yes, it's fantastic. It's the best. This is the most arcane subject in open source to me, is keeping all the licenses straight and what their requirements are. And this came credit to the TechPod Discord server for tipping us off to choosealicense.com. It's the most straightforward, like plain human language explainer of different open source licenses that I've ever seen. It's literally just like, hey, what are your goals for this project? Do you want it to be shareable? Do you want people to use it without a lot of disclosure requirements? Do you want this or that? And it literally just sort of directs you to, here is the best license for you.
And there's an appendix there, Brad, that's really good, that has a grid that's like 50 lines long with all the different the common licenses, and like whether they're good for commercial use or distribution or modification or patented use or private use, or whether you have to disclose source, whether they're copyrighted, blah, 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 blah. Anyway, the upshot is, if you want to contribute code to a project that already exists, you're probably going to use the license they use. If you want to use a code in a commercial project and don't want to disclose source, you probably want to use a permissive license like the MIT license. And if you want to make sure that everybody else who uses your code in the future has to also share that, you're going to use a version of the GPL or one of its derivative licenses.
Yes, yes. And to be clear, I mean, if it's not obvious already, this stuff is kind of the domain of what kind of lawyer, like contract lawyers, I would say, right?
I mean, it's like a mixture of contract and copyright, right? Because like the
Sure.
license is a contract that describes your use of. The thing is, I feel like there's not that many people that actually work in this kind of law. Like the FSF and folks over there do a lot of this stuff.
Sure.
The Free Software Foundation. Sorry, I did an abbreviation there. But it seems like, I don't know who the experts are on this, because these things
Right.
don't come up that often in court, I guess.
You know, and I would guess a lot of those experts work at large corporations, because I think, you know, we've touched on this here and there, but like every major tech company on the planet uses a ton of open source stuff in their day-to-day, in their products, in their infrastructure. You know, every Google, Facebook, Microsoft, Apple, Netflix, you know, all of the heavy hitters and everybody on down the ladder has probably got some kind of open source compliance department or some sort of legal team that makes sure they observe this stuff, because it is important to comply with the licensing terms.
Yeah, and this is a thing that happened in the 90s a lot. You know, Linksys is a classic example of, they saw some open source code. They wanted to do a router and wanted an OS for their router. So they just said, hey, we're just going to use this Linux thing. And then they didn't share the source code for their changes to the Linux kernel that they used. And there was a brouhaha. And the end result is that they had to release all of the proprietary code that ran the radios and stuff like that in their routers. And all of a sudden there's like 3 open source router firmware projects that wouldn't have been able to exist otherwise, because we probably didn't have access to whatever the low level firmware was for the routers. So
I love a good open source brouhaha, a hubbub, a kerfuffle. I mean, you'll occasionally, like to this day, you'll occasionally see people out there getting angry at company X for not releasing the source code or making the disclosures that they are required to, but it kind of turns into sometimes like a David and Goliath sort of situation, right? Of like, I assume you have to challenge them in court to actually make something happen if they don't do it on their own, right? And that kind of raises the question of who is the David in this situation? Who's going to bring the legal challenge if a large, wealthy company is not actually complying?
Well, okay, so there's 2 phases. One is the everybody yells at the big company phase.
Yes, which is often effective.
Yeah, often effective, I would say. The other phase is that the legal action is pushed. And often I think you'll find that the other companies that use that same software or that contribute to that same software will probably be willing to throw some legal weight behind it, because it's important. Like the companies that are investing in this software, it is exactly that. It's an investment. They're doing foundational work that benefits them, but it also benefits everyone else, and they want to continue making sure that happens.
Sure.
In practicality, a lot of the software that is in that space outside of like Linux kernel and some big core applications ends up being MIT licensed, is my understanding.
Sure.
Now, there are some things you can't do in licenses that were popular for a little while in the like late 90s, early 2000s. You can't put clauses in your license that require things that are vague in the legal sense. So you can't say, don't be evil in your license, because there's no legal definition of evil, which continues to surprise me personally, but here we are. Basically, the license has to describe requirements and deliverables that are concrete and legally sound, or else, and the risk of doing that stuff, like putting in the kind of cutesy "don't be evil" clauses, is that your entire license can be invalid, and then you have to relicense the entire project, which involves getting everybody who's ever contributed to it to agree to the new license, and it can be a real problem. There've been controversies, well, like a lot of controversies, it turns out. We touched on the viral licenses a little bit. The idea that you can take a piece of code, if you download that code and use it in your project, then all of a sudden all the other code in that project is then subject to the requirements of whatever license the original, the downloaded code was subject to. Like, I know of a great many instances where this has happened, where somebody who didn't know what they were doing or didn't have a open source compliance department helping them downloaded some GPL code, put it in their app, and then all of a sudden something that this company had spent millions of dollars doing was out of compliance with their open source requirements, and they had to open up a really expensive piece of proprietary software
that they rather would have kept closed, right? Probably.
I can't imagine that most companies are spending millions of dollars on software that they want to keep. Yeah, that gives them competitive advantage that then they want to have to contribute back to the community. But good for us, I guess. I don't know.
Right. A thing you'll find in this world a lot is that at their core, software licenses are focused on the practical because, again, this stuff is legally complicated with copyright and everything, and you have to make sure the stuff is defined. But there are some, let's say, kind of crusaders out there that take on an ideological bent about the whole thing, where they're kind of, and that's where like these viral licenses come in, where there are people who are kind of on a quest to make everything in the world open source, and that's where these viral licenses become somewhat controversial.
Yeah. Look, without the people that were on the quest, we wouldn't be where we are today. So I appreciate totally those folks.
Yeah, that's totally fair.
But the nice thing is, if you are writing software and you're in a situation where most of those controversies are solved these days by just using a different, more permissive license, right? Like, you don't download the GPL software, you use something else instead, or you write your own version, and then it works itself out.
Yeah.
Okay, the last part of this license bit, because we've been going on for a bit here, is what does this require for like normal people? For each of the different people along the way, each class of person, what does it require? If you're an end user who's just downloading the software, it really doesn't matter at all for you. You're not modifying. Most people don't modify the software that they use. You're just downloading it from GitHub or your package repository or Windows or whatever. You just download the software and run it. It's no issue. Even if you download it and reuse the code for use personally on your own computer or for your own projects that you're not sharing and not commercializing, you're fine. You don't have to reshare that code unless you want to, right? Like, nobody's going to know that you've done anything wrong. If you make changes, if you improve the software, it's really cool if you contribute those changes back up to the community. That would make you a valued part of the community. It's not necessary unless you want to. And there are perfectly valid reasons for not wanting to get involved sometimes in the communities around some of these larger projects, especially. If you're using the code for commercial use, Brad, you are then subject to the requirements of the license. So if you are selling the software, if you are taking software that is open sourced with one of the open source licenses, and you do not follow the requirements, if you don't disclose that you're using that open source software, if that's what the license requires, if you don't share your code changes to that open source software, you are out of compliance with the license, and the angry people on the internet are probably going to yell at you and or sue you if you are too egregious and using it in a gross way.
And you would deserve it.
Yeah, I mean, look, you're benefiting from the work of the ages. That's the thing that's neat about open source is like there's a through line from a lot of the software that we use that runs the internet today and runs a lot of our OSs today to work that was done in the 60s at Bell Labs and places like that. And yeah, it's part of the common good.
Absolutely.
And commercial use just means, hey, I'm selling a product that uses this software, pretty much.
Right. Okay. Have we reached the end of the legal talk? I believe that's it for legality in this episode. Is that correct?
Look, if you only take away one thing from this entire talk about licenses and copyright, it's that everything that you create is copyrighted by default. And you have to actively do something to assign that copyright elsewhere, which is what software licenses and Creative Commons and stuff like that are for.
Right.
That's it.
Okay. Legal talk over. I'm going to go take a shower and then let's move on. All right, let's move on to a section that we have entitled Working with Source Code.
Ooh.
This is where we kind of want to just define a lot of the nuts and bolts terms that you might run into about kind of everything about working with open source software, collaborating with other people, handling your code, making sure that everything is kept straight.
Yeah.
Kind of the nuts and bolts of the process.
It's like a little bit logistics and a little bit playing nice with others.
Yeah. Yeah. There is we are kind of code adjacent, I guess I would say. We've dabbled with some scripting here and there, but I've never been like a contributor to a major project or anything. But even from the outside looking in and talking to people like Jim Bailey on OBS, you realize how much working on, especially like a sprawling open source project, is about working with people, not just code. There's a respectfulness to maintain. There is a collaborative spirit. There is an oversight capacity. It's a pretty complex organism.
Like anything else, it's about giving and taking feedback.
Yeah. Yes.
But there's also a component of there's a lot of lingo around this that is new, at least was new to me when I started using the software 20 years ago. It's often confusing, and we're going to kind of dig into a little bit of how this works so that hopefully people understand it better.
Can I confess a secret about me?
Yeah, what's your secret?
I love defining lingo.
So this is your favorite thing?
Yeah.
Welcome to Brad and Will Define Lingo. I'm Will.
I should write a dictionary. I should be in. Okay, let's move on.
Yeah.
All right, so we've just got a bunch of terms here that we thought we'd kind of run down the line that you may have run into. As we said, these terms are pretty commonly thrown around these days. Okay, let's just go down the line here. So maintainer and contributor.
Yeah.
Now, Jim referred to himself as a maintainer of OBS in that first episode we did. Maintainer is kind of the air traffic controller of a project. Somebody who pretty much has all the components in mind, right? Like what the different software pieces of it are, which contributors are assigned to different tasks. They keep an eye on all of the changes and new modules coming in from contributors. They manage the code review process, which we'll get to. They're kind of the overseer of the project.
Well, ultimately, they're the arbiter of what goes in and what doesn't.
Yes.
Right.
Yes.
Like in a traditional closed source environment, like if you were working at Microsoft, probably and you're writing code, probably there's somebody above you that's telling you what to do. And that may not be the case on a typical open source project. It may be, actually.
Yeah, in fact, if you remember that interview we did, if you listened to that first episode, we asked him, like, hey, how does somebody become a contributor on OBS? And he actually said, like, hey, just show up and start working on something that you think is cool. Like you don't have to ask. You can actually just start because again, the maintainer is, among other things, responsible for deciding if your work goes in or not. So you can do the work, but there's still a review. So you don't have to like ask permission. You can just, if you have the skills, you can just show up and become a contributor.
Yes. So a contributor is just somebody who's going to the Git page or the repo, depending, we'll talk about repos literally next, but going to the place where all the source is stored, grabbing the thing they want to work on, making some changes, and then sending them back up to the maintainer.
Right. Yes. Okay. Repository.
Or repo.
Or repo, colloquially, is that's the modern term for the totality of the project. All the source code lumped together into one repository.
So you're saying if I was a person, a male who works in repositories, I would be a repo man?
I suppose that would be true, yes.
Okay, so the repo is where the code lives.
Yes, the repo is all the code. And in a modern context, that lives on... There are a lot of services out there. GitHub is the one you'll hear about the most. GitLab is another one. Bitbucket. There are a lot of commercial services that all have free tiers. Anybody can just sign up and store code there at a basic level for free.
Yeah.
But the repo isn't just a dumping ground for a bunch of source files. There is functionality that's mostly managed by Git these days, which we'll get into in just a minute. But I think the two terms that we've got here that are probably the most important to understand within a repository are branches and forks.
Yeah. Forking, I know, is very controversial.
It can be.
People get upset about forks.
I think it's certainly got a practical purpose.
Branches, not at all controversial.
No, so branches, from my understanding, and you've worked in this world, having worked in VR software development and now game development, you are a little more adjacent to the stuff that I am. You're shaking your head.
I uploaded some stuff to a branch last night. I'm branching left and right over here.
Okay, I decided that build servers are out of scope for this episode, but I would love to talk to you about build servers sometime.
Build servers, everybody hates build servers right up until the moment that you need to do something that the build server does. A build server is the thing that takes the code that's in the repo and builds the applications for you.
Or in a dedicated fashion if you're a big software house that needs a fast machine to do that for you and not, okay, we're getting out of scope.
But it's important because the idea, like, when you're talking about software that needs to be compiled in order to run, so we'll talk about interpreted and not interpreted languages in a bit, but a lot of software that you use, like if you want to use a copy of OBS, that software has to be run through this thing called a compiler, and you need a machine that does that, and that machine does it for all of the different places that people can run OBS. So you need a version for OS 10, and a version for Windows, and a version for Linux, and a version for 32-bit Linux, and probably a version for like Raspberry Pi Linux, and all the 50 million places that people are going to want to run this software. And if you do that all manually, it would be one person's life, and they would be a miserable, awful, it would be sad for them. I wouldn't want them to do that. But you also have these pieces of software they're called build managers. They'll do it all for you. Anyway, the upshot is...
You're not speaking from experience or anything.
I don't want to talk about it. It's not... Like, being the human build manager is not a good place to be.
See, that sounds fun to me, but maybe you don't know...
Briefly.
You don't know what you don't know. Okay, let's get back to brass tacks here.
Yeah.
Back to basics.
Yeah.
So a branch is essentially a different version of the project within the repo. Like the repo is the umbrella over the whole project, and you can branch it and essentially have kind of a separate version of the software to make changes to without necessarily committing those to the main branch, to the main kind of core official version. You can branch to experiment with other features or to add things that aren't necessarily relevant to the main version. I guess the key...
The metaphor is tree.
Sure.
Yeah. The metaphor is tree. The repo is the trunk of the tree, and the branches are the sprouts that have grown off of it in different ways.
Right. But from a human perspective, branches are kind of generally managed by the maintainer, the people that run that repo, right?
Oh, yeah. And typically people work in one branch or another. So, for example, if you're working on a project like OBS where they have nightly builds, and then they also have like the most recent stable, and then maybe one version back or two versions back if they're doing security updates and stuff like that, you'll do your work in whatever the current branch is, right? And then you can either move stuff up to the newer branches, to the further, I guess they're further downstream. I always get that part mixed up. But the things that are the future versions, you can move stuff from the current version to the future versions, and just copy the whole thing wholesale every once in a while. Or you can backport individual submissions either to the older versions or forward port them to the new versions.
You're making me realize how many nature metaphors there are in open source. There's the tree and branches, there's upstream and downstream. Upstream, like you can think of the stream, you can think of water flowing. Upstream is like the kind of more foundational projects. Your Linux distro, your underlying tech or whatever, like the changes that happen upstream will trickle down to downstream projects that are dependent on those more kind of low-level things.
So typically people use branches. Well, one of the more typical uses of branches, people use them for all sorts of different things. Often you'll use a branch for the current version and then the next version. So you'll have a team that's maintaining the current version, a small team that's maintaining the current version of the software. But then most of the people who are working on it have moved on to the next major point release. So like if you're on version 1 on the public release, most of your developers will be working on version 2, but those changes may not, you don't want those changes to roll out until they've been tested and thoroughly reviewed, and you're pretty confident that everything's reliable. So you work in the version 2 branch while the users are using the version 1 branch. Also, I've seen projects use branches for different levels of hardware support. So if NVIDIA rolls out a new version of their video acceleration hardware, then you might have a branch that is only for using with specific video cards or something like that. And that kind of stuff happens as well.
Maybe a little personal example just to kind of drive the point home. For the little music server that I run, I ran into a bug that I wrote. There's only one developer on it, and I wrote to him, and he was very friendly and said like, oh yeah, thanks for the bug report. I'd like to help squash this. He branched it and added literally 5 lines of code that just added some extra logging and asked me to compile and run it and send him the log file. Like that was a good, very quick, minor example of, because he didn't want that extra logging functionality in the release version, so he just branched it and said, hey, compile this branch and let me know what it says. That's just a quick example of what that might be useful for.
Well, and the neat thing about using software repositories and source control, because these two things go together, they're like two sides of the same coin, right? Is that you can look and see, okay, Brad submitted... He submitted 25 changes between December 25th and January 5th. And we had a bug come up in one of the areas that he works in regularly. So we can go through and you can figure out you can see exactly what code you submitted during a certain time period. So you can kind of go back. It makes it easier to find bugs. It makes it easier to deal with if there's some sort of overall problem or whatever. Like you can roll back individual changes if you find stuff in regression testing or whatever that you don't want to have in the main app. So, and like I said, you can also take, like for security fixes, you can take security fixes for the current mainline version, the version that most people are using, and roll them back to the older versions that maybe some people are stuck on for a variety of, I'm sure, good reasons.
Yes. Okay, so that's branches, which again exist within the repo. Forking is the process of someone external to the project coming along and just cloning the whole project and essentially having their own local copy, which of course, they have to comply with any licensing terms, but other than that, they've got all the source code and can do whatever they want with it.
So this is it's like the promise and the threat of open source. If you use something and the people who are making it aren't doing a good enough job for you, and you have the time and energy to build a community around your vision for that project, you can just say, you know what, I don't like how this is going. We're going to make our own. We're going to make the Will version of this, and we're going to get out there and do our own, and there's nothing you can do. Like, occasionally it's good.
I think it could be good more often than not, I would say. I mean, what you're describing, I think, is the sort of shots fired version of open source and forking. Like, here's maybe the most positive version of this that I can think of is if somebody discontinues a project. If it's popular, but they just don't have time, they got a new job, whatever. You can fork a project that the original maintainer is no longer supporting or working on and take it in a new direction and continue. That happens all the time. Like, projects will be picked up by other people. Sometimes they'll be renamed, sometimes not. I guess usually when they're forked, they're renamed. But that is a good positive example of forking allows somebody else to keep something alive that otherwise wouldn't be. But yes, there are notable examples over time of projects that are very much still alive and being worked on that another group, let's say, does not agree with the direction of or the quality of or whatever, and decides, hey, we're going to take your work as it exists right now and make it better in a way that sometimes can rub the original people the wrong way.
Well, and kind of like the unfortunate thing is it is an example of people not being able to play nice with others, right? Which always feels bad. The idea with open source is that we all work together, and instead of one person working on one thing and one person working on another thing and one person working on another thing, the sum of the whole is a bit more than the additive bits of each contributor.
You're not wrong. I want to be careful not to vilify forking too much here, though, because if you go to like any major project on GitHub and you can see publicly who has forked it, I mean, there will be hundreds to thousands of forks that people have made for themselves, because, it can also just be used for learning, for experimentation, stuff like that.
That's exactly, like a lot of CS classes now, your assignment is to go fork a version of a project that's a fairly large project, download it, make your own version of it, and learn from that source code. So which is another thing we didn't even talk about. A benefit of the open source life is that, hey, you can see how, like, there's nothing I can learn from how Microsoft wrote Windows or Word, but I can totally open up OBS and see what, how they're doing complicated video compositing in that software, which is really cool.
It is such a far cry from the CS classes I took 20 years ago. I mean, I cannot imagine how much richer and more robust and diverse the learning material is out there now for people learning to code.
Look, you're going to make a command line CD library app no matter what, Brad. It's just one of the things we all do.
Here's my lemonade stand written in C.
Okay, so we have the repos. We talked a little bit about version control and like how you can roll back individual changes. It seems like everybody uses Git these days.
Yes, for version control, I think Git is definitely the standard. I don't know if you may be aware of alternatives that are still in use, but I'm not. I think pretty much everybody the whole world does. Like Subversion was kind of the standard previously, 15-ish years ago.
Yeah, SVN was popular for a long time. There have been a bunch of different things over the years. Like the game development world uses Perforce because it handles binary, like image and texture and model files and stuff better than Git does.
Yeah, so Git was literally conceived and written by Linus Torvalds, the founder, original developer of Linux.
That explains a lot.
Specifically to version control the Linux kernel itself, but it got picked up by other people and everyone ran with it. And that's where all the GitHubs and GitLabs of the world came from, was as a kind of more user-friendly web front end on Git that allows you to exploit all the functionality of it in a little bit more of a friendly way and a more collaborative way, because obviously web pages are very easily shared among developers, so you can kind of dig into everything as a group much more easily than Git, which is essentially primarily a command line tool.
Yeah, it's a command line tool to interface with a database of code, basically. Right. GitHub also layers a bunch of other stuff on, like issue tracking and wikis and things like that, so that it's a little bit easier to manage.
So Git is the core technology that lets you say, hey, make a new branch, hey, roll these changes back, et cetera, et cetera. It's the thing that handles all the moving pieces under the hood. Okay, so shall we move on to pull requests? I feel like...
Yeah, pull requests are exciting.
Pull requests, PRs, like I see coder friends on Twitter that throw those terms around a lot, and I assume people who aren't in this world see that stuff and may wonder what that means. Pull requests, it might sound a little counterintuitive, but it actually means I have made changes to your project. and I would like you to integrate them.
I would like you to pull them into your code.
That's the metaphor, is you are pushing changes to a project and you are asking the maintainer you are requesting the maintainer pull them into the project. And then,
well, I mean, you're not even saying, hey, it's often, especially if you don't have a relationship already with the project, it's often more, hey, I did this thing. Will you take a look at it and see if, like, did I do this right?
Yes.
Do you think this is worth integrating? Or would you rather I take a different approach to it?
And I guess that's where like a code review comes in, right? There's a mediation process where things are reviewed and the maintainers determine whether it is up to snuff, if it's something they want in there, if it is done to their standard, et cetera.
Yeah, and code review and pull requests both are handled, like, these aren't, hey, this is the way this works in this software infrastructure. These are more organizational tasks. Right. So, like, some places, like the game studio I work at, when you're doing a code review, the person who wrote the code and somebody else sits down and they talk through how it works so that everybody understands what's going on. And part of that is like bust proofing the application, right? So if something happens to somebody, at least one other person there understands how it works and they make sure that the comments are good and everything's well documented. But it's also, in an open source context, is also to make sure that people aren't adding in things that are untoward. Because in the world of software development, there are good ways to do things, and there are ways that work, but that will cause massive performance problems or stability issues or whatever other things. And code review is intended to find those problems before they become problems.
Yeah, or especially these days, security issues.
Yeah, security issues.
Exploits, and as much open source software as runs the internet these days and other infrastructure, like finding security exploits. That's why like vulnerabilities in major open source components make so much news, right? Because they can introduce all kinds of problems, and that's where kind of a code review comes in as much as possible.
You want to find them before they're a major problem is the goal.
Yes. Yeah.
So what if you want to contribute, Brad? Where do you start?
I guess I would say it's somewhat dependent on the project and where they host it. You know, if it's a GitHub or a GitLab repo, or there are some old school projects that have been around forever that kind of run their own version control on their own websites or use older systems. But by and large, newer stuff is on one of those major platforms. And, you know, I guess if you've got the skills, just start going through the code and see what you think you could contribute to. Maybe contact the maintainers.
There's also issue trackers usually on most big projects, right? So they'll have a list of, you know, here are all the outstanding bugs. Here are all the outstanding feature requests. Here's all this. As Jim said, often it's like, hey, I want this feature in this piece of software. And if you have the ability to go build it, you can go build it and then say, hey, I added this thing. People are going to be stoked for the most part if you add something of value to the larger audience.
You showed up and did work unrequested, and generally they're going to look kindly on that. Yeah, the issues tab, like you mentioned on GitHub, is a fantastic place to look at like things that might be wrong, that may not be getting enough attention, that you could go look at and try to solve if you have the skills. Another way you can contribute, even if you're not a coder, is writing documentation.
Yeah.
I've talked to developers on our TechPod Discord who absolutely say, hey, even if you don't have coding skills, you'll find a lot of open source projects, especially the smaller ones out there, have pretty sparse documentation.
Yep.
Because developers are too busy writing the code to write how to use it.
Often the people who are capable of writing the code are also the least capable of writing the how to use it documentation.
Sure. Or just don't have the time. So if you get involved with a project that you like a lot and feel like it could have better documentation and you're capable of doing some technical writing, that's another way you can contribute.
There you go. Okay, Brad, I'm convinced I should be using more open source software. How do I get it on my computer?
Boy, that's a question with a lot of answers.
I can just go to the App Store on my phone and download it, right? That's how it works?
Sure. After it's gone through about 8 other steps. It does depend on the project. I mean, some projects, even on a place like GitHub, will compile themselves and just release installers or binaries that you can just download and run. A lot of the projects out there, though, are not prepared for use in that way, right? In some cases, you have to go to the repo and download the source code yourself and know what to do with it, which can be a lot for people who don't live in the development world already.
I find that doesn't happen so much anymore for things like it's unusual that you find something that's not compiled.
Yes, I'm maybe speaking from personal bias a little bit here, kind of dabbling in things that are pretty esoteric, like music streamers and stuff like that. But you're totally right. Like the OBSs of the world, any genuinely popular thing is absolutely just going to be prepared for use.
Like if you want to use Audacity, you don't go download the source code and compile it yourself. Yes. You go to their page and you download the version that's already compiled for your OS of choice.
Right. Right. Do we want to touch on programming languages just a tad here?
We can, yeah.
The differences between compiled and interpreted languages.
Yeah, this is a thing that comes up, and I think a lot of people probably don't understand that necessarily.
Yeah, and we talked about this a little bit when you mentioned build servers at work. Compiled languages are the traditional, like you've probably heard of C and C++. I think even my mom had heard of C++. Like that's a pretty well-known term. Those are very old languages. The gist is those are written in like human readable code, like we mentioned. But that code is not what the CPU is running. That code has to be translated or compiled into machine code that the CPU can execute directly. So the upshot is if you have those text files of code, you can't do anything with them other than compile them into an executable that actually runs.
And the reason we do the compiling step is because it makes them much more performant.
Yeah, it's much faster.
Yeah, basically the compiler step optimizes based on the different types of CPUs that are available. And we don't need to get into how it works because I frankly don't understand. But the upshot is it does the math a hell of a lot faster than it would if it was just running through a text file and doing a bunch of if-then loops.
Tell you about object files and linkers. No. So the distinction is important because there are a lot of more modern languages that are, I guess, interpreted is the best way to describe them. Those are things like Python, Java, Ruby.
Now, Java's tricky.
Yes.
Because Java is interpreted, but it's also can be compiled, and like there's a whole...
I think that's the case for a variety of languages that can be... Like, I guess the point is like an interpreted language can be run directly from the source, right?
Yeah.
That you don't have to compile it. And that primarily that has applications for running things multi-platform, that you can put out one Python thing, and as long as people have the Python environment set up properly on whatever their operating system is, theoretically, I'm sure people who work with Python all the time are yelling right now.
I have Python 3.7, 3.9, and I think 3.5 installed on my computer right now for reasons that we don't need to get into.
To say nothing of the 2.x versions that are still hanging around for one reason or other.
Oh, God. Yeah. But the upshot is,
yes,
the interpreter on your computer handles the math. So basically, you can download a flat text file. Like I have a Python script that runs a MIDI interface to talk to my audio mixer. I have a Python script that does some file management stuff for me on the reg that just clears out my downloads folder every couple of days.
Yes. I use a Python command line utility to tag MP3s for podcasts, to add metadata to podcasts, and that runs on, I run it on Windows, I can run it on my FreeBSD machine, on my MacBook, as long as you've got the relevant framework like a Python or something like that set up.
If you've ever used a batch file, that's an interpreted,
sure.
It's just hey, you telling your computer to do these things in this order, and maybe there's loops and stuff too.
Right. It's kind of verging, I mean, it's not the same thing, but like that's kind of on the same spectrum as like shell scripts on the far end of that. Like a batch file is kind of an example of a shell script, which is, there are people out there certainly who will tell you that shell scripting is programming. Maybe as other people will disagree, but
look, scripting is programming. I think it's safe to say we should be more inclusive as a group. And
I agree.
There's a reason when I took CS100 in college, I learned C. I think these days they do a lot of Python and stuff like that because it's a much more practical, useful tool for most people than learning how to write compiled code.
Yeah, and actually the thing that you'll find, even if the longest shell script I've ever written is like maybe 300 lines or something, but like you'll find when you get into that stuff, I mean, the logic and problem solving and control flow are really not different from what you'll see in an actual programming language, right?
It's just a matter of scale.
Yeah. Conditional statements and loops and like all that stuff are conceptually the same. So that can be like a gateway to kind of deeper programming.
Yeah. If you understand pointers in one thing, you understand them in other things too.
Pointers about the point that I washed out of. Anyway, let's move on.
So, okay. So the trick with both of these is that they have dependencies. So often if you're running a Python script, it'll say, okay, you need to have these modules installed, right? Basically, it's saying, hey, I don't know how to work because I need some functionality that lives in these other pieces of software.
Yeah, other
and that
libraries.
applies to both compiled and interpreted code.
Yes. So dependency is a term you will see all the time in the open source world. It basically means prerequisites, as the name implies. It means you need these other things installed before this thing can run.
And the neat thing, there's a bunch of different ways to get those dependencies installed. Sometimes there's package managers are probably the most common one in the open source world.
Yes.
And in Windows and OS 10 at this point, or Mac OS at this point.
Pretty much every operating system. Yeah, even the ones you don't traditionally think of as like command line oriented or development platforms, open source. I'm going to read what you said out loud as we were planning this episode. When package managers came up, you said, like an app store, except you don't have to pay for the apps. Also, it's command line. Also, they've been around for 20 plus years.
Yeah. And it turns out not having to compile all the applications you run on your machine makes things a lot easier.
Yes, that's kind of the biggest advantage of a package manager is that other people, maintainers of different programs generally are the ones doing this. They have done the work of compiling the application for you for whatever operating system, CPU architecture, et cetera, that you're using. So you just type a command and it installs a ready-to-run version of the thing.
Yep. So Linux, like each distro has its own package manager at this point. There's apt for Debian and all of its derivatives. There's DNF and Yum for Red Hat and Fedora. There's Pacman for Arch. BSD ships with PKG, or do they call it package? Or I don't know.
Tend to call it package, but yes, the command is PKG.
But like a relatively new thing. It's a relatively new thing on the Windows and Mac OS. Well, I guess MacPorts has been around on the Mac OS side for a really long time. But Chocolatey is a kind of third-party package manager for Windows. Winget is this thing that Microsoft added a couple of years ago, I guess.
A couple years ago now. Yeah. Winget is Microsoft's attempt to make an official package manager for Windows, which I feel like has been a little bit stop and start so far.
I think the problem is it presents a really large target profile for bad actors in my experience. Whereas if you install, Chocolatey, install Discord in Chocolatey, there's only one thing called Discord because somebody there is keeping an eye on that. And on the Winget side, sometimes there's a bunch of other stuff called Discord that is not Discord and maybe is actively bad for you. I don't know.
Yeah, a package manager is only as good as the sanctity of its library of software.
Yeah.
That has to be a place where the people who handle that stuff are keeping an eye on like security exploits, like you said, malware or kind of unsavory versions of things sneaking their way in there. And that's happened. Like you'll see, macOS has Homebrew and MacPorts just to round out the operating systems, but a lot of programming languages also have package managers. So like Python has pip.
Yep.
There's Node for JavaScript, et cetera, et cetera. Rust has Cargo.
PPM is one of them. I don't remember what PPM is even for, but it's something I've had to use on the occasion.
Yeah. So
it's Perl, I think.
Okay, sure. So like in the web development world, JavaScript is huge, and like there have been cases of bad versions of JavaScript packages getting out there, and like that's a way to kind of Trojan horse security exploits into places they shouldn't be, right? If the packages are not vetted all the way.
Yeah, it's a big potential problem, and it's one of the reasons you want maintainers for your projects. In addition to needing maintainers for the project, the operating systems run maintainers who keep an eye on the sanctity of their package managers.
Right. So there's one more kind of more modern way of getting software, which is these containerized app formats. We talked about this a little bit, I think, in the NAS episode, because we make use of this stuff ourselves in some places. But it's like Docker is kind of the classic example, or absolutely the most widespread one.
Yeah.
There's Snap or Snaps, like the apps are called Snaps.
Which Snaps.
Snaps. Oh, Snap. That's Ubuntu. Canonical is the company that makes Ubuntu. That's their containerized app format. There's Flatpak. Flatpak is common. I think it's on the Steam Deck, right? Like there are.
Yeah, that's an Arch thing, I think, right?
I don't know if it may be. That may have originated in Arch. I'm not sure. But these are the application you want to run and all of the dependencies it needs to run in a sandboxed, like self-contained package, essentially.
So it's not quite a virtual machine because it's running on the same kernel.
Right. It runs on the host OS. It's not a full virtual machine, but it is a sandboxing framework, basically.
Well, and it's a way for you to port your entire, like once you have the application set up and is ready to run, it's a way for you to carry that forward. It makes that application portable between machines. So you can set up your Docker app. Your Docker container then is something that you can pick up and move from one Linux machine to another Linux machine, and it will run the same way on both machines, assuming Docker is set up correctly.
Generally, it's a way of avoiding dependency hell. It's like, hey, you're running this older version of Debian that doesn't have up-to-date libraries for X, Y, and Z that you need, but those newer libraries that this application requires are in this container, so it doesn't matter. You just run, it uses what's in the container that it needs, not what is outdated on your system. And that's just a cleaner way to do things.
So you're saying I don't have to have 3 different versions of Python installed on my system?
Let's not be hasty.
Okay, Brad, we've reached what I like to think of as the potpourri section of our lingo demystification episode.
Yes, I have ceremoniously named this section in the show notes miscellaneous.
But I mean, these are all the things that kind of didn't fit into one of the other buckets. Some of these things people know, like I feel like I have a pretty good understanding of what an operating system is.
You think that, but I mean, yes. Okay. So everybody knows what an operating system is. Windows and Mac OS are the classic widespread mainstream examples. The BSDs are other examples of operating systems, the FreeBSD, OpenBSD, NetBSD. Mm-hmm. But like there is distinction here because Linux is kind of the odd one out, right? Because Linux in and of itself is not an operating system.
Well, but there are different flavors of BSD, just like there are different flavors of Linux, right?
Well, it's not the same thing. The BSDs, this is kind of maybe a common misconception. Those are completely different groups with different kernels, different drivers, different everything. Like OpenBSD is totally distinct from FreeBSD. They are totally separate.
Wait, I can't run OpenBSD code on FreeBSD?
Sure. Hey, you want to clone the repo and do the work yourself. I'm sure you can do anything you want.
Oh, wow.
But yes, that is, I mean, that's extremely in the weeds even for this podcast. But yes, the BSDs are like totally different galaxies from each other. But the thing with Linux, I mean, the thing to understand is, I mean, so we want to demystify what a Linux distribution is, or colloquially a distro. You'll hear that term all the time. Linux by itself is just a kernel, which, as the name implies, is the heart of the operating system. It's the thing that handles, process management, memory addressing, security, hardware access, stuff like that. Linux is just a kernel and drivers. I know this. I know this sounds like the most actually thing ever. Linux is not actually an operating system. It's just a kernel and drivers.
Is this like the old Windows argument where you're like, man, Windows 95 isn't really an operating system. It's just a shell that runs on top of DOS?
No, because there is actual legitimacy to this line of thinking.
Okay.
The reason it's important to understand this is just to understand what Linux distributions are, which are like a Linux distro is what makes Linux an operating system. So any given distro, common examples are like Debian and its derivatives like Ubuntu, like Red Hat and Fedora, Arch. I mean, there are a bazillion
of them, yeah.
Linux distros out there. But essentially, any Linux distribution group will take the Linux kernel and drivers, which are generic, which are common to every Linux distro, and they make their own decisions about what to bundle with it.
Like window managers, the things that draw windows, the web server that it includes, all that kind of stuff?
Totally, like everything. Mail server, like anything that's in there, they make, but even like low-level stuff like the init system that handles how processes are started and all kinds of stuff like that. They'll have their own documentation, their own bug lists, their own everything. So like every Linux distro in a sense is kind of its own operating system, but they do all share that really common low-level technology.
Even though theoretically you can run, assuming you're running the right version of the kernel in each one and have the right dependencies installed, you should be able to run the same software on Debian and Arch and Red Hat and all that, right?
Generally, yes. I mean, like we said earlier, they have different package managers, and it's interesting, like hopping from Linux distro to distro, like you will certainly be familiar with certain common concepts, but there are always like all kinds of little differences. Like distro stores these types of config files in a slightly different place than this other one. Where does this distro put all of its third-party binaries that you install from package managers? Oh, it's in a different directory than, they use user local? Like, okay. You know what I mean? There will be little tiny distinctions between practically every Linux distro that you use.
This is a Royale with cheese situation.
Kind of, yes.
Like they don't have the metric system in Arch, so they're using user/local instead of var/db.
Right, but there are like kind of family trees of Linux distros. Like I said, Debian is one of the oldest, and there are a bunch of major distros like Ubuntu that descend from that.
Yes, Debian begat Ubuntu, but not begat. I don't know what Ubuntu begat, but got it.
Mint, and Pop! OS, and there's a zillion. Arch is kind of its own weird thing. Like Red Hat is very corporate, but Fedora is a free rolling version of Red Hat, which I guess maybe is something we want to get into next year real quick.
So stable and rolling, these are ideas that are important to you, I think, depending on how you want to maintain the system, right? How much work you want to put into maintaining a system.
Yes. Distros often, sometimes the terminology might differ, but they'll usually designate themselves as like stable versus rolling. Stable means like generally it's kind of locked in, like everything that's in there is locked in terms of even the third-party stuff that's installed. They say, okay, for this release of Debian Stable, all the packages that you will get through the package manager are locked. We're not going to upgrade them. We're not going to do anything to this thing unless there are like really important security fixes, basically. It's for servers. It's for this machine needs to run. Everything on here is tested and said to be stable, and we're just going to put this mail server in the corner and never touch it again, right?
Well, yeah, the differentiation is, hey, we're going to do bug fixes and security fixes versus we're going to do feature updates, right? So you don't get feature updates on a stable release beyond what it ships with. You should get security updates and you should get bug fixes for X number of months, however long they agree to support that particular release.
Right. So like in Debian land, like stable is the one that is like frozen in time and will often be kind of outdated in terms of the packages that are available. And then it has testing and SID, which are much more, those are rolling releases. Those get updates much more rapidly and are much less stable as a result. Red Hat is the same thing where like Red Hat and CentOS, the derivatives that are considered stable are stable. And then like Fedora is much more of a bleeding edge where development happens, right? So essentially,
what's the downside of the rolling? The downside of the rolling release is that you can get dependencies out of sync and have things suddenly stop working for you.
Yes, there was a conversation on our Discord recently about someone who had an Arch install. Arch is like as bleeding edge as it gets, I think, or pretty close to it. People were saying like, hey, if you walk away from an Arch machine for like too long, for too many months without updating it, and then you just run a global update and try to update everything, there's a good chance it won't boot after that. Like things will break if you don't keep up with updates and like really keep an eye on stuff. So
okay.
And I guess it's worth talking about these terms because even outside of operating systems and Linux distros and all that stuff, you'll see as you are testing open source software, like you'll see here's the stable version, here is kind of the next version that's beta or testing. Like you'll even have nightly builds of stuff. which, as the name implies, like they're literally building versions every single night.
Well, and so the nightly builds can sometimes turn into like a staging release or a test release, a release candidate. Then people will test those for a while before they get promoted to be the next mainline release of the application. But Microsoft doesn't release nightly versions of Word or Office for the most part. You can go to the OBS page and download a nightly version of OBS if you know where to look and you go to the right section of the website.
Yeah, and you're willing to bear whatever, bugs or issues might exist because it's kind of untested code, right?
Generally speaking, don't use nightly releases for work unless you have a specific need to. So for example, if you have some sort of new hardware that you need supported in something, you might actually have to run nightlies for a while until the version that's the current nightly build or the current testing build becomes the next mainline version. Anyway.
Right. Yes.
Okay, so then we got command prompts. This is that little window you open, you type stuff into, and then things happen.
Yeah, I mean, just real quick, everybody knows what a DOS prompt is, I think. But in the open source world, in the software development world, shells, command prompts are alive and well. Like people use them every day, all the time.
Yeah.
I guess the big distinction here for me is the shell versus the terminal. Terminal program is kind of, or a terminal emulator is what you'll hear a lot of people call it because they are descended from like physical terminals and teletype machines from, 50 years ago. The terminal is just a program that like literally draws the text on the screen. It's the thing that handles showing you what is happening in the shell.
Yeah.
The shell is the thing that is actually interpreting all of the commands that you were giving it. And different shells have different things built in for command completion and command history and stuff like that, scripting.
Like formatting your command line prompt and all that kind of stuff.
Yeah,
like all of that, you can do different things and you can customize all of those.
Right. And lots of shortcuts and things like that. Examples of popular shells are like Bash. I mean, probably almost everybody has heard of Bash who might be likely to listen to this podcast. There are more recent shells in the Unix world like Z Shell and Fish. Microsoft has PowerShell, which is a kind of a more advanced shell for Windows that you can kind of optionally install.
But you can get Bash on Windows these days if you install the Windows Linux subsystem for Windows. So it turns out everything has become kind of the same as everything else, even though it's still different in a way that's weird and kind of nice.
It's great. I love it. I love the fact that you can just kind of use the same shell on every operating system these days, basically. It's great for workflow, it's great for development and stuff.
Okay, let's talk about desktop environments a bit.
Yeah, I guess I think we touched on this a couple episodes ago. These used to be called window managers back in the day, I think.
Yeah, KDE and GNOME.
Yes, or Window Maker, not OpenStep. What was the one that was like Next Step? I'm dating myself here. Let's move on. But yes, like desktop environments, it's the GUI basically. It's like KDE, Plasma, and GNOME are two of the big ones. There are a ton. XFCE is like an old school looking one.
But it turns out, like if you use Linux for servers or stuff like Raspberry Pi installs that you're not connecting to a graphical interface, you probably are never going to see the desktop environment. You're probably never going to install this stuff because it just takes up resources that you don't necessarily need to run on the computer.
Right.
If you do end up using them, the neat thing is, and this is something I discovered early in the early days of Linux, because often your distro of choice would ship with both GNOME and KDE, and you could switch back and forth between them by toggling the boot script, the window manager launch script. Basically, they control how the window Chrome, like the framing around your windows in your GUI, which applications are installed by default, how you add and remove applications, the interface for the package manager of your distro, all kinds of stuff like that. And you can change those willy-nilly on Linux, it turns out. You just go to the package manager and grab the other one you want and then set the window manager launch command to use the new desktop environment. And it just kind of works, which is weird.
This was something that some people on the TechPod Discord wanted us to clarify for people. I think there is a misconception out there these days that to change window managers desktop environments, you have to kind of reinstall a new distro. But especially because like things like Ubuntu these days, you can download a version of Ubuntu. Like by default, they ship GNOME, but there's Kubuntu that ships with KDE instead, and Cinnamon, stuff like that. You will get other downloads of Ubuntu with different window managers, but you don't have to do it that way. You can absolutely just install different ones in your existing install and then just switch back and forth and try stuff out and find what you like.
So then the last thing we wanted to get to in the potpourri / miscellaneous section is that open source really extends beyond just software. Creative Commons, which we touched on earlier, is an open source kind of inspired. It's an open licensing structure for creative works, whether it's written or imagery or graphical art or photographs. You can basically assign a Creative Commons license to anything that you've created that isn't necessarily code that says, hey, I want to share this with the world. I want to either retain all rights, allow it for non-commercial use, allow it for anybody who shares alike, or any combination of the above. And there's a programmatic way to describe that on the images and on the text that you create, so that it works in the same way that like a MIT license or a GPL license or whatever as you would like.
Yeah, Creative Commons is great. You'll see like a lot of photos on Wikipedia. You'll see the photographer has licensed this under Creative Commons. That means you can reuse it however you like with the proper attribution. I feel like a great example of this is Stack Overflow, the perennial I need help with my tech problem or coding issue, Stack Overflow is a question and answer site, but all of those questions and answers that are crowdsourced, are user provided, are also licensed under Creative Commons. So like that information, regardless of corporate ownership changing hands of that site or whatever, like that data, those questions and answers will continue to be freely accessible.
Well, and Wikipedia is the classic example of a Creative Commons licensed work. All the text that's created for Wikipedia is, I think, on CC attribution share alike, which means you have to attribute where it comes from and you have to share any changes you make to it with other users downstream. So they're not saying, hey, you have to push the changes back up to the original source. They're just saying, hey, you have to make your changes freely available as well. And I believe that most of the images on Wikipedia are supposed to be Creative Commons licensed. There's an occasional copyrighted one that pops up with a big giant warning on it. But a lot of people do their documentation as a Creative Commons work, so that then you can work on it as a group and share it and change it, and et cetera. There's also a whole world of open hardware out there, which is it's been happening. Like, open hardware has been a thing that has been around for 10 or 20 years at this point, but it's just starting to become really common in the last few years.
Yeah, you've got here I didn't realize the mechanical keyboard community apparently does a lot of hardware design sharing.
Yeah, there's a lot of mechanical keyboards that are either open firmware, open hardware designs, or both. So, for example, people wanted a mechanical split keyboard years and years ago, and the people who manufacture keyboards were like, well, there's no market for that. So somebody was like, okay, well, I'm going to design the board, and then somebody else was like, I'm going to write the firmware, and somebody else designed a case that could be laser cut or 3D printed, and then they built it all on, I think, MassDrop at the time, which later became Drop.com, as one of the first user-built split ergonomic keyboards. The QMK firmware, which is kind of one of the main open firmwares for mechanical keyboards, is an open source project. But also people do post their board designs. So they post the designs for the boards, they post the designs for the cases, and depending on which part it is, it'll be either licensed under a software license, or it might be listed under a Creative Commons license if that's more appropriate.
The Mister project, which is kind of a retro gaming attempt to recreate old video game consoles with an FPGA chip, is pretty much entirely underpinned by open hardware design. It's based on the DE10 Nano, which is a commercial FPGA board that is owned by a subsidiary of Intel. But all of the hardware add-ons that people have designed themselves and grafted onto that thing to perform, different types of video outs and extra memory and all that stuff, like those designs, those PCB designs are just out there. And, there are a lot of resellers that make them and will just sell them to you, but you can also just go take those PCB designs, send them off to PCBWay and get your blank PCB in the mail. And they also provide bill of materials that describes, these are the capacitors you need. These are all the parts you would need to solder to this board. You can literally get those designs, get all the parts, and just make them yourselves, because the people who designed those boards have just put all that stuff out there.
Well, and the neat thing about this is that people have also built secondary Mister product board designs that let you plug a Mister D10 Nano into one of these daughter boards that then slots into like an arcade system,
right,
with like a JAMA connector or something like that. So it's like a slot-in replacement for a classic arcade machine.
Yeah.
I think the cores are also open source for the most part. There's a handful
Yes.
that might not be, but the actual FPGA cores that emulate the hardware on the FPGA are open source as well.
Yes.
For the most part.
Yes, those cores written in, I think, mostly VHDL, which is like a hardware design language, essentially, as I understand it. But yes, you can absolutely go look at all the code for like the Super Nintendo core, the Sega Genesis core, stuff like that.
And then there's a ton of other stuff like 3D printers. There's a bunch of drone designs. The controller that a lot of people use in drones is an open source hardware design that has open source software. I believe that some of that's actually running on the helicopter that's on Mars right now. So there's open source software running on open source hardware on Mars, is my understanding, but not 100% of the hardware. I haven't actually looked at the specs for that. There's a whole world of stuff that is open and, just absolutely cutting edge.
I mean, people are out there building their own mice and trackballs these days with designs that are being shared amongst enthusiasts and that sort of thing.
Yeah.
So the last open hardware thing, the thing that I think is the most interesting to keep an eye on is RISC-V. which is
Yeah, of course.
It's an open source CPU architecture, which is being positioned as a competitor to ARM. ARM is the CPU architecture that runs basically every mobile device on the planet at this point, but that's controlled by a company. The ARM instruction set is licensed out to companies like Apple and Qualcomm and Samsung, right? Mm-hmm. Companies that design and make actual ARM chips have to pay licensing fees to ARM to make those chips. RISC-V is essentially kind of in the same ballpark in terms of functionality, but it is a free and open source CPU instruction set that I think companies are starting to adopt and make actual products out of. I don't know where that's going to go. Like, that's pretty high level hardware design stuff, but the fact that there is this alternative CPU design scheme out there that anybody can just take and modify and use and fabricate actual chips out of is kind of mind blowing to me.
It's anybody with a big asterisk, right? Because
yes,
you still have to have access to like really bleeding edge fabs and all that kind of stuff.
That's where the fabricate their own chips part comes in. Yes,
but yeah, it's a new paradigm for chip design, and it'll be interesting to see how this goes and see if companies band together to work on something toward a common goal. Because like, I don't feel like the RISC-V stuff is something that we're going to see shade tree chip designers coming out of the woodwork and contributing to in the same way that we do even big projects like OBS or LibreOffice or one of those kind of things that everybody's heard of.
Yeah, the chip design, I think, is still very much the domain of large hardware companies. But the question for me is, like, do we see a RISC-V-based phone at some point in the next 10 years?
Yeah, and I'm also super interested to see if the RISC-V stuff follows the same path as traditional open source software, where projects that run for a long time kind of start out at a deficit compared to the commercial products. And then as the improvements pile up and things continue going for a longer period of time, eventually they supplant the closed source alternatives as a general rule. So... yeah, no, so that's it. Hopefully this was helpful and we demystified some language and de-lingoed some of the lingo. You know your difference between a repo and a repro. We didn't talk about repros.
Oh, no, we didn't. That's a whole other topic. Branches and forks, operating systems and distros, shells and terminals.
Permissive and non-permissive licenses, the MITs and the BSDs. What's the HAPs there with all your acronyms? As always, the FOSSPod is brought to you by Google Open Source. They bring all the value of open source to Google and all the resources of Google to open source. And if you're curious, if you want to know more about Kubernetes and the Docker shim deprecation, if you want to demystify that business and talk to some people from VMware and Red Hat and a bunch of other places, they're running a workshop on March 31st that you can sign up for right now. It's free. Anybody can go. You can find out more at opensource.google/events.
Can I try that? Okay.
Yeah,
demystify the Docker shim deprecation. Demystify the Docker shim deprecation. Demystify the Docker shim deprecation. I got it. I made it.
The FOSSPod is edited by Sabrina Hill. I'm Will Smith.
I'm Brad Shoemaker.
We are here every other week at fosspod.content.town. You can find out more there, and we will see you next episode. Bye, everybody.